All right, this is episode 3 of the Money Button documentation series, where we are covering not just Money Button itself, but also all of the sort of basic information that you should have if you want to be able to build Bitcoin applications. So today we're talking about hash functions, which are ubiquitous throughout all of Bitcoin. So what are hash functions, and how to use this library to do hash functions. Do you guys have any comments or questions before I dive into my terminal here?
No, just a little comment that I don't know if it's going to happen now, but usually we refer with the same word that is hash to the function and to the result of the function. So usually for the context you can deduce it, but for someone new could be a little confusing. So
good point.
Just that.
Good point. Yes, there is a difference between the function that computes a hash and the result that is also called hash. And also there are different types of hash functions, like we're going to be talking about cryptographic hash functions, which have certain sort of properties that are not necessarily the same as the properties you might have in other types of hash functions.
Yes, actually, if someone comes to, I don't know, for example, the Ruby world, they usually say hash for the maps or the dictionaries.
Right.
So yes, it's a word for a lot of meanings in this. You're covering basically cryptographic hash.
So yeah, I guess, I mean, just briefly before we begin. So those are hashes. They are called hashes, and you can do hashes in really trivial ways that are very fast. The problem with that is that they don't have the properties that we look for in a cryptographic hash function. We want cryptographic hash functions to be not invertible, for example, and many of those hash functions are invertible. So we want to be able to have a hash and have no idea what went into it. So that we can use it in cryptography. Okay, let me share my screen here. So I'll just show, first of all, how to do hashes with this library. Okay. You guys should be seeing my screen right now, I believe.
Yep.
Okay. So let me load the library here as usual. Now, we have a bunch of hash functions defined on the crypto.hash object, bsv.crypto.hash. We have several different ones. I'll briefly explain sort of what the different ones are later. Let's just pick one, though, that's very common in Bitcoin, which is SHA-256. This is one of the most common hash functions. And what we can do is basically, if we have data, so I'll do something like, oh, this is my data, buffer.from. This is my data. I'm taking a string, converting it to data, so it's a buffer. Now I can do things like bsv.crypto.hash data, or sorry, bsv.hash SHA-256 hash, which hash function am I actually running here, on my data, and I get back an output that looks like this. Now I'll put it in a slightly more readable form here, hex string. So this is always the output of SHA-256 is always 32 bytes long. If I do things like, data.length, should get the 32 there. So SHA-256 is widely used in Bitcoin. We have a few other hash functions. So like, for instance, double SHA-256. This is also widely used in Bitcoin because double SHA-256 is what's used to hash a block and to hash a transaction. So the thing that miners are actually running over and over and over again to mine Bitcoin is actually double SHA-256. And it's the same thing that we use to identify transactions.
So that should be the same that applied twice, the first one, right?
Yes. So the idea is basically, so you could test that empirically. So we do things like, if I do SHA-256 of my data, and then I do SHA-256 of it again, I certainly ought to get the same thing. And whoops, okay. Crypto.hash. And then let me output it to a string so we get the correct format here. Okay, so if I SHA-256 that thing twice, and I compare it to the double SHA-256, it is exactly the same. So that's all it is. It's applying the same hash function twice. Now, there are a couple other ones that are just important to Bitcoin that I'll, go ahead, did you want to say something?
No, it's okay, continue.
Okay, so let me explain a couple of other ones that are just relevant to Bitcoin. So one is RipeMD 160. This is just a different one. And what all these hash functions do, I didn't write this down in the documentation, but they just do a bunch of sort of arithmetic operations on the data input. And things like or I should say binary. So things like XOR and things like that, it does in an algorithm. So they're all just unique ways of hashing data that have certain properties where no one has figured out how to break them yet, basically. So RIPE-MD 160 is just a different algorithm, and it gets you a shorter hash. So this one is 20 bytes long rather than 32 bytes long. And just for the record here, there's another one called SHA-1, which is not used in Bitcoin, but it is used in sort of other areas. Like SHA-1, for instance, is used by Git. So for people that have the hash of your commit in Git, what that is actually, oh gosh, what that is actually is the SHA-1 hash of your commit. Now, Bitcoin actually has several of these built into the protocol itself. So if we look at like bsv.crypto.hash, actually most of them are built in except SHA-512. Also, HMAC is kind of a different thing, which I'll cover in a second here. SHA-512 is not built in, but these other ones are. So you can actually, inside of a script, inside of a Bitcoin transaction, you can actually execute these. So the one that matters most now, so we've already covered double SHA-256, which is used for blocks and transactions. We also have SHA-256, RIPE-MD 160 of my data. This, actually, that's not going to work because I need that hash and I need an E. RIPE-MD 160, RIPE-MD SHA, it's not 156, 256. Okay. Now, this is actually the hash function used to compute a address. So a Bitcoin address inside of a transaction simply is the SHA-256 RIPE-MD hash. So this is SHA-256 first, and then you apply RIPE-MD 160. That is what a Bitcoin address is inside of a transaction. There's another point that we'll get to later when we actually talk about addresses, which is they're then base 58 check encoded, which we'll cover what that means as well. But so the ones that matter basically that are widely used inside Bitcoin are SHA-256 RIPE-MD 160 and then double SHA-256. So these are the ones that show up over and over and over again in Bitcoin and inside applications of Bitcoin. You see these widely used. You also see SHA-256 by itself widely used as well. Now, there's another thing in here that you should be aware of called HMAC. Now, what is HMAC? HMAC is a function that is a way of combining two pieces of data that you want to hash. So it is often the case that you want to do something like this. I want to go bsv.crypto.hash. Say SHA-256, and I want to do something like data 1 plus data 2. I want to concatenate them. The problem with this is that there actually are various attacks that can happen with concatenating secret data with public data and then giving a hash publicly. And there are a number of attacks that have happened in history of internet services where they use a hash to have some type of secret on their server that they hash with data that's controlled by an attacker, and the attacker can control the length of data. And various attacks have occurred where systems were compromised due to doing things this way. So as a general rule, what we do is basically anytime you ever want to hash two pieces of data together, if you're doing it for like security reasons, like you're having like a key or something, you should probably use HMAC. And so we have built-in methods for that, which are SHA-256 HMAC. So using HMAC, I can then take two pieces of data. I only have one here, but let me make another one just to prove the point here. So for our data 2 equals, this is my other piece of data. And then just to remind ourselves, whatever data was, it was something else. So we have data 2. So I can now hash I can HMAC SHA-256 HMAC.
Data 2 is not a buffer. I don't know if that's.
Sorry? Say that again?
Data 2 is not a buffer. It's like a string. I don't know if that's okay.
Good point. Before I do that, then data 2 equals buffer.from data 2. That does matter because you'll definitely get weird results if you don't control for types and all that. Okay, now I can HMAC them And well, I guess I shouldn't have converted that one to a string. I can convert to a hex string. Is what I should do there. Okay, so this is just HMAC. So HMAC is something that that is widely used for systems. It's not used inside of Bitcoin itself, but basically if you're creating some kind of system that involves some type of server-side key or something like that, you use HMAC. I think it's also used inside ECIS, if I remember correctly. You do something where you HMAC a private key with the data that you're encrypting or something like that, and you can sort of sign data in a particular way. Yeah, but go ahead. Do you want to say something?
Can you concatenate more than 2 pieces of data? And the order is important?
So HMAC, yeah, good question. So to answer both those questions, first of all, no, not inside HMAC itself. HMAC takes 2 values. They call it key and data. And so it's always a function of 2 of them. And the order certainly does matter. If I change the order here, I'll get a different result. However, if you do want to do 3 pieces of data, which I'll just do as a proof of concept here, let's say buffer.from third piece of data, I can do a series of HMACs where I, HMAC the thing that I already had there, and then I add the other one in, hash.sha256 HMAC of my new data with the HMAC of the other pieces of data. So if you want to HMAC 3 things together, you just chain the HMACs, and you can do that. So that's how you do multiple if for some reason you want to do that. I've never actually encountered that, because normally what you do is you normally the only reason why you do this is something like you normally have some type of secret or key or something that's different than the data, and then you want to hash it with the data, and so you use HMAC. It's not normally the case that you have a bunch of them. It's normally you just have the data and then some other value, and so you use HMAC for that. So there just isn't usually a reason to HMAC multiple times in a row. But we can also do SHA-512 HMAC, which is used in a number of different standards. And SHA-512 has a property that it outputs actually 64 bytes instead of 32 bytes. Okay, so we can look at the documentation. Any questions or comments about this? The rest of this stuff, guys?
If the results of the order of the data change depending on which order you organize them, how do you decide which one will go first and which one will go second?
Yeah, so it depends on what you're doing. Normally it's a protocol level thing. So if we look at actually here, what I'll do is to answer that question, I think it's helpful to actually look at the code. So let me stop the screen share, and I'm going to go open up the source code for the hash file, and which I have sitting here. Okay. So if we go actually look at the algorithm for HMAC, what HMAC itself does is it takes in a hash function and a data and a key, and does all this stuff, which includes running the hash algorithm on it, filling various data with these just numbers that are determined to make it practically impossible to like reverse anything, and filling stuff and whatnot, and then ultimately hashing the whole thing again and producing the output there. So what you would normally do is it's called data and key because it's like almost always used where you have some type of data, like a file, and then you almost always have some type of key, like a session identifier or something like that, or a user name or a public key or something. And so it's written in that way so that you just always do it that way. So it's usually obvious, and it doesn't really matter. Like you could swap data in key and the properties of it are the exact same. So it just depends on what protocol you're using. So when we see HMAC show up again in some of the protocols, it doesn't matter. You just have to pick one order and be sure to do it the same way always, basically. Okay, now one brief comment just because we're looking at the source code. All these hash functions are actually coming from the Node.js crypto library, which does work both in Node.js and a web browser because it uses Webpack, which has a bunch of pure JavaScript implementations of these hash functions that do work inside of a web browser. And HMAC is the only thing that's like actually implemented in the code here. Everything else is basically just comes from libraries. Okay, so let me stop screen share again, and I will show the documentation that we have for stuff. Okay, so we basically covered everything already in the documentation. Now, this just gives a brief overview of it, including some properties that we basically discussed already. So these are properties that you want out of a cryptographic hash function. Basically, the most important one is if you have a hash, it should be basically impossible for anybody to know what the value was that was hashed without iterating every conceivable value. That's the most important property of a hash function. And there are hash functions that are broken, like MD5. MD5 is sort of known broken. There are ways to crack it where you can more easily determine the input using MD5. So no one uses MD5 anymore. That one is known to be broken. And even SHA-1 is suspected. In fact, actually, I think there was actually an actual attack on SHA-1 in the past couple of years. So Git is now like planning some very, very long process of migrating from SHA-1 to something else, because it's going to be a huge pain to migrate every single Git repo in the world to use a different hash function. But Bitcoin doesn't have that problem. Bitcoin uses the more modern hash functions, and none of them have any known weaknesses. But it is very likely that at some point somebody will find a weakness of some kind. And so we'll just have to assess the situation when that ever occurs, whether we have to fix the crypto in Bitcoin. But currently that's not the case. So the SHA-256 and RIPE-MD-160 and SHA-512 have not been broken, and hopefully won't be broken for a long time. So this just summarizes what are the functions that we have here, how big is the output, and what is HMAC, and how to use it. So that's what we have here in the documentation, in the screen share here. Any comments or questions about any of that stuff?
A few.
Yes.
Why do we use more than one hash function in Bitcoin? Why is not just one?
Interesting question. So let's see. We don't really know, right? Because Satoshi just launched Bitcoin and didn't explain anything. So why does it use several different hash functions? So I can try to guess. First of all, it uses some that are secure. So the first of it didn't use MD5, probably because Satoshi was smart and knew that MD5 was broken. So don't use that one. Some of them have certain properties, like why is an address the SHA-256, RIPE-MD-160 of the SHA-256 hash of a public key? Well, this has certain properties. If you don't need to reveal the public key, it's actually good to not reveal the public key, to reveal the hash instead, because imagine someone were to actually break elliptic curve cryptography. Well, you have two hash functions on top of that. They'd have to break both hash functions, RIPE-MD-160 and SHA-256, just to get your public key so that they could then break that to actually get your private key. So it actually is a way of layering these different algorithms so that if you just give someone your address, they can't crack that. They have no idea. And even in the future, when some of these are weakened, they probably still will not be able to ever crack your private keys from an address, because you have to crack all of these different things. And so if one of them has a weakness, the other ones are completely different. So that kind of explains addresses, why it would make sense to hash it, and then why it would make sense to use two different hash functions on it. As far as why is a block a double SHA-256 hash, I do not have a good answer to that one. Why is there a second hash? I don't know, because when you mine, you're already hashing it a lot. Probably something like, if I had to guess, you want it to be longer than an address. An address is something you actually share publicly. It makes sense for that to be shorter, so it makes sense for the second hash to be RIPE-MD-160. In the case of a block, you don't really have the same problem. You want it to be long because you want plenty of room for the miners to mine on it. They need to create a hash that starts with a long number of zeros. It actually makes sense to use a longer hash for that, which would be SHA-256. A second hash maybe provides benefits. So maybe if the hash were ever weakened, well, it's not just one hash, it's two of them. So the problem with that would be something like, if you ever were able to invert, a hash or weaken it in some way, you could mine more efficiently is what would end up happening. So anyway, I don't really have a good answer to that. My best guess is something like it makes it harder to weaken it. But that's only a guess. I'm not sure if there was a reason for that, and I'm not aware of any sort of public publicly known reason why there would be a second SHA-256 hash. I can only guess.
Right. Okay. And well, the other thing is that, well, you mentioned that BSV actually uses Node implementation, so probably they are pretty fast because are
Yes.
just implemented in the
Yes.
language. That's pretty cool.
Yes.
Oh, and another thing I wanted to mention that is I always see the same, like when you're talking of hashing for cryptography. Another important thing to have in mind is not only not use cracked hashes, also not be creative. Like if you use SHA-256, that works. That's widely tested. It's
Yes.
it's not a good place to be creative. Basically, you should just use the thing that you know that works.
Yeah.
That's why it makes sense to use these kind of tools.
Yeah, I agree. That seems like pretty sensible advice. It's something where, like, there are people that are experts at this stuff that have designed these hash functions. And it would be very weird to someone to make their own hash function or go off and, unless you're actually an expert, there would be no reason to do something like that. Okay. So unless there are any more comments or questions, we have, so people that want to learn more about all this stuff, please visit moneybutton.com to get links to everything, including our Telegram group and our documentation. The documentation is at docs.moneybutton.com. Our Telegram group, where you can talk with us and get help and information about all this stuff, is t.me/moneybuttonhelp. And we'll provide links to, in this case, there's not that much. We will provide some links to some basic information about the hash functions, but they're a little bit easier to understand than elliptic curve. So, but nonetheless, there is plenty of information out there if you want to know details about how these various hash functions work. Okay.
Right.
All right.
Great. Bye.
Bye.
Goodbye.